There were
No, it's, yeah.
there were no participation trophies.
I don't think it's before.
Yeah, that is completely feel it.
And finally, why
I think the versions of things that were they like, but then whatever reason
Yeah.
they have.
Yeah, that's probably right.
The gray switch on the top gives you the image.
I work the polls.
The PAL better than NumFOCUS.
I think that
I was gonna brought up.
And generalize around that.
This is your participation trophy. This is it. You're the gold now. Good luck.
That's good, they need it, yeah, they need
You're a voter now.
it.
You can have
Over it.
Yeah, you're.
I can, that sounds okay, right?
I like, I'm looking for that, but it's like, it's like I wonder what my life would have been like.
Okay.
I
Yeah. It does, right.
It's your phone.
So, probably the participation trophy, you're the best.
You've been bad.
They don't fear the quick self now.
Right.
It was the right train, just the wrong
That's
person.
something.
Yeah, we
Uptown, downtown.
It's the same thing. They made the mistake of following it. And I made a mistake.
But it's okay, we just got back on.
Yeah.
Yeah.
Because sometimes actually it's allowed to be able to change the side, which means you need to reswipe.
Right.
Oh,
Exactly.
It's supposed to remember this one.
Yeah, but I was the one with the job, so that's why.
He wasn't with us.
Our swiper was gone.
He's what I remember today, brought her home.
It's confusing to me.
Now I look at
For the one local.
that page, we have.
Yeah.
All the time, and then went to the page one.
Oh, yeah.
And then make sure you read them before you get out. Don't
No
follow the
instructions,
crowd.
no
That's the worst thing.
When we do this little thing.
20% of the time, I follow the crowd, and then what's wrong?
Right, and like,
Yeah, that's
This
true.
one is like the most.
That's true.
well, I feel like.
Is there-
Everybody's very happy.
This is how.
All the
you
readers, all the TikToks,
We
yeah,
can't.
exactly.
We can fit.
Yeah, we
Weekend is the
Yeah.
The science,
Yeah.
I think, is good.
It doesn't change.
I mean,
It wasn't exactly that, but it was pretty much.
do all the preparation work during the weekend, so during the weekend. The train is ready on the C line,
Right.
we'll do the stuff of the C line, and it's like,
God.
it's too
Just random,
complicated, so.
random on the weekends.
Maybe it's supposed to be trained, pull one up.
You did.
That's what they do a pretty good job of advertising that on the website, Expose API, so there is.
But on the other,
Sometimes you can do that.
Right.
It's just scary. It's getting better.
Just like so bad, like new things.
Yeah, this is road.
As you can see, it's not.
There are too many people in this room.
Oh, interviews.
Right.
It's perfect. Yeah. Like, she's a jacket.
Yeah.
It's also business.
Yeah, like, I could see some to stop something.
Yeah, jacket. Yeah. Yeah.
And several people work on that.
I don't know what it's like it's just so relief. Did you rate things about?
I think for sure.
your phones or something.
Can use that.
It's not like the first one, so you ask them.
Yeah. Nationality, your family nationality. Like, I just
On
would
the
get
weekends,
ask you about.
if you are
That's
staying
like a
in
no. You didn't
Manhattan,
even think past that.
it's environment, always somewhere they are in construction. So they will, as for sure, one of those ones will be construction. That's how they get worked out.
Right.
So never assume.
Yeah.
But they'll tell you on the app.
I'm going home tonight, so. Paperwork.
That's not the review, that's
Now
also.
we're on.
Oh, nice. That'll be good.
On weekends, it's very,
Yeah.
My brother's there.
Yeah,
He's a
okay.
nurse, so,
That's perfect.
so that,
No, there is, but it's a.
so.
I priced out taking the train. I priced out taking the train down. So many different trains. I think the North Station, then take the subway to South Station. And then I have to walk to go to the subway from the North Station and everything. So you got 8 hours. And so marginally the same of money.
Right.
Just to consider.
That's surprising.
It's crazy to me. North Station. There's no train service from North Station
Yeah.
to South Station. It's a two place out there.
Yeah, that's right.
All the way from Maine.
What is, can you tell, like,
Yeah, I mean,
by his
yeah, I can get
lifestyle,
to,
that kind of, like, was he always this way?
usually the Boston Garden. So, that's where the train stops. It's right there,
Yeah.
TD Bank.
Okay.
He's still a student, believe it or not.
So that's
And
probably
that keeps
the
him.
people, I feel like,
It's
who
just
kind
no.
of retired.
Yeah,
Big deal.
he's in the hole, because it's a little frail.
No, that's super.
I think I'm probably a little bit.
Right, one of the cameras. I went on that one with the airport.
You're in Boston, you're in?
Yeah, from New Hampshire.
I live in Vermont.
I lived in Boston for 3 years. I got lost
Okay.
in my neighborhood.
Yeah.
All these highways.
Well, and all the roads are bypass.
Yeah.
That's how they the roads.
I used to go into Boston, well, back when I started in Boston.
Yeah.
Right in the middle of the big construction.
Yeah.
Every time we went in, it was a different way. And I think it's just I learned one way.
Yeah.
That road's gone.
Yeah.
Just get
Right.
And no matter what I did, because I would go 93, that north south.
Yeah.
Every single time I go somewhere, going west. I wonder if this is.
So it, yeah, just.
I don't know how I did it every year. This is before.
Yeah, that was before smartphone.
Yeah, you don't worry about stuff.
When I tried
Don't even
to
worry about it.
go this way, I always go up, which leads me to a totally different route. And so I went again. I got lost. Everybody got lost.
And then the fun thing too is just trying to get around during the beginning of the academic year, and then you have to worry about whether or not the store driver will walk off because the store. Every year, at least one person runs their moving truck into the bridge and starts to drive.
Use up.
Hey, sure, yeah.
Hi everyone, welcome to the first talk of the day here. So Jim Dowling is the CEO of Hopsworks. He's an established researcher in system software for AI and an associate professor at KTH Stockholm and Trinity College Dublin. He's also the author of a book on building AI systems at O'Reilly. He organizes the annual Feature Store Summit and co-organizes PyData Stockholm. Welcome, Jim.
Thanks. Great to be here. I was here in May, actually, the talk was very nice. Same building. I'm going to talk today about how we can build AI with AI. And it's a lot closer than you could think. So how can I build an AI system with the help of large language models? We're going to look at classical AI, so we'll think of as decision trees, machine learning models. I'm going to talk about it. I work at a company called Hopsworks, a little bit about Hopsworks, but very little really. But what we're really talking about is, how can I get by with a little help from LLMs? It rolls off the tongue very nicely. So we don't want to replace programmers, but we want to enable a new generation of programmers. So, you know, I as an educator, I think a lot about, you know, I've been running a course for building AI systems for the last few years at KTH, and you see where people get stuck. You know, they have a great idea, so they have this project to do where they have to identify some dynamic data source. They have to identify a prediction problem and build the AI system. And where you get stuck a lot is in how do I get the data? How do I wrangle the data? How do I, you know, transform the data? That's where the weaker students will get stuck. The good ones will obviously make by, but how do you enable that generation of programmers to be more productive? Maybe they know the concepts, but they don't know the syntax. So, and I'm going to talk a little bit about the high level where I think we're going and where I think we can be more productive. Probably many of you use large language models today. I know that I do daily. I'm constantly in GPT or Claude, and I'm basically getting it to write code, particularly in domains where I'm not maybe as experienced. Now, this week, or last week, I should say, the Google CEO came out and said, a quarter of our code is now generated with AI. People go, that's amazing. You know, that business people go, that's incredible. And if you read the article on Hacker News, you know, they kind of pull back the curtain on this and say, well, what does that really mean? It means that a quarter of Google's terminal inputs are written by glorified tab completions. That's kind of one way of looking at it, right? And a lot of developers, you know, I talk to, will look at this with a very skeptical eye, and often it's right to have a skeptical eye. You want to, you know, is this thing real? Is something happening here? And if you follow the same thread in Hacker News, you see that, you know, the lead developer in this particular project came in and wrote, you know, something quite, you know, a justification for the work they're doing, and maybe opening up a little bit more details on what the challenges are that they see. So this is a serious area. This is something that's happening. You know, we can be skeptical about it and say, you know, I'm not going to be out of a job. You know, I work on something that's really hard. But we've seen such progress in recent times. I think we need to treat this with a lot of seriousness. So what the Google lead developer said for this particular developer tool, he said, okay, we care about the recommendations. We have a lot of infrastructure around testing and monitoring and ensuring that the code generated is high quality. We also look to make sure it adds to the productivity of the users, and they do a lot of randomized and A/B testing around the productivity of the developer to make sure that this helps them move faster. I use it personally, so I can say from personal experience, I'm a much more productive developer with an LLM than without one. And they're not the only company doing it, so Eric Meyer at Meta, he's a very well-known programming language researcher, and he's been talking a lot about using LLMs to write programs. They have a very good paper from a few years back where they kind of looked ahead to the future and said, what are the most important things we can do with LLMs to improve our productivity as developers? And what they've been working on a lot is code search, so being able to search through your code for something. Tab completion is what code recommendation is, if you can think of it, right? So, but code recommendation is not just tab completion. So I'm going to talk a little bit later on about how I use it. I don't use tab completion all the time. Often what I'll do is I'll go to GPT and I'll describe the problem. So I need to describe it in enough detail so that GPT can produce working Python code for me. But if it doesn't produce working Python code, what I can do is I can feed the output of the errors back into GPT and say, please fix this bug. And that's what Facebook talked about here. So I'm sure a lot of people do that now. If you get some bug, you don't really understand it, you go to GPT or Claude, you paste in the bug, and then you get a recommendation for how to fix it. So I think that's going to become part of our developer tooling and developer suite. One other thing they didn't touch on, which I use quite a lot, is what we can think of as meta programming. So you want to solve a problem, but you don't know what's available. What are the strategies I can use? And we know from using LLMs, I know from personal experience, is that you can say, do this, and it will just do it for you, but you don't know if you did it right or did it best. So often you have a meta step where you say, okay, I want to solve this problem. I'm interested in, you know, computing synthetic data. So I have an example later on of how to create synthetic data in LLMs. And you go and ask an LLM to do it, and it'll write code and it'll work, but it might be very inefficient. So you then have to have a meta step where you say, okay, what's the most efficient way to do this for this particular framework I'm using? So, that step of finding the best libraries, the most efficient implementation strategies is something that LLMs can help a lot with. And this is the area of information retrieval. And obviously they're prone to hallucination. A lot of people say don't use it for information retrieval. But I think in this case where you're trying to write a program, getting a recommendation for a library is not a dangerous thing as such. So at a very high level, what we can say about LLMs, where do they fit into our stack from when we write programs? Well, at the top, without LLMs, we have domain-specific languages. People use them sometimes. I'm not a huge fan. They kind of have their day in the sun and then they get out-competed by general-purpose programming language eventually. And we have IDEs. IDEs are always here to stay. So IDEs are incorporating LLMs already for recommending code. We know that there's IntelliJ have built-in support, and obviously there's GitHub Copilot and other tools. And then there's a lot of tooling around programming languages. So, CI/CD pipelines and testing and so on. But the programming languages themselves, where do I see the LLMs fitting in? They're there basically to either generate code for your programming language, or to generate testing strategies for tooling, or for your IDE, or if you have a DSL, you can generate code for your DSL. And we still have the whole stack below that. We still have a programming language that will be either compiled or interpreted with some intermediate representation, and then ultimately it'll be executed machine code on the stack. So LLMs are pretty much a natural evolution of programming languages, where we're going from rigid syntax, which is what we have in existing programming languages, to natural language interface, but we still will need the same rigor to be able to define our problems so that we can generate the correct code. I think that's going to be a challenge for the next few years is, what level of knowledge do you have? And I'll talk a little bit about this later, is, what are we actually doing when we're prompting, when we're asking questions? What is the strategy we're doing? I'll talk a little about knowledge evocation is really what we're trying to do here to generate these programs. You will need to know abstractions, you will need to know the basics of algorithms, you'll need to know things like the computational complexity of different approaches. And if you don't, you can get help from the LLMs, of course. But there's going to be a new way of thinking about writing programs with LLMs as a key interface for this. So, does it work for some programming languages or not for others? Meta say that it works for most. What's interesting is that if we look at programming languages and their verbosity, most people know that Java is a very verbose programming language, and this is an interesting study that was highlighted here, that we can see that the average character count in Java for these different algorithms in this table here is much higher. So it's roughly twice as long in character count in Java compared to Python. So Python is a very concise programming language, which helps in some way, but LLMs are not really scared by verbosity either. Human understandability is the most important thing for LLMs. One of the problems with LLMs we'll have, however, is if you have a lot of, let's call them unusual symbols or characters. So, I come from the research lab that invented Erlang. If you're familiar with Erlang as a programming language, it has some pretty funky syntax, with exclamation marks and arrows and things like that. That's not super helpful for LLMs. And what you'll find as well is, I'll mention in a minute, but SQL is currently a second-class citizen for LLMs. It's not very good. LLMs are not very good at generating SQL, and partly that's to do with human readability. So when people write SQL programs, they don't tend to have a lot of comments describing the SQL programs. It's not as common as in a Python program. You can imagine a pandas program, people have comments explaining what each step is doing. So the LLM has been able to be trained and garner the knowledge about how to create these Python programs. With SQL, we don't have that same code base out there with, I think that's one of the reasons. Also the fact that it's declarative, this makes it a bit harder. So SQL is very hard, and there's very big teams globally working on SQL. It is a declarative programming language, and it's based on math, so the relational algebra set theory. And it seems to be at the moment that it's much harder for LLMs to write declarative programs than imperative. And this may not be the case. Maybe in 6, 12 months, 2 years, 5 years, we'll come back and we'll see that LLMs outperform humans. But at the moment, we can see that for human performance, this is a well-known bird benchmark for SQL. Humans way outperform LLMs. And that's not something we're used to. We're normally used to saying, well, LLMs for humans on a lot of tasks. So we're at a stage, so if we go back and we think about this diagram we have here of LLMs generating programming languages, and you're interested in this, and you say, well, what am I going to do? You got to pick a programming language at the moment. Some of them will work well, some of them won't. So I argue that Python is actually in a good place at the moment. And in particular, I'm going to look at data processing in Python. And Python is an imperative programming language. It's concise, it's human understandable. All of these things help to make it easier for LLMs to generate Python programs today. And the LLMs that we have out there are trained on GitHub source code. That's one of the largest places where they'll find source code, GitHub. There are other places like Stack Overflow. Me personally, I work with Hopsworks, and 12 months ago, when I tried to write code in pandas or polars, and then use Hopsworks to save data frames, it didn't work. It was picking up old code from a V2 of our API. And I didn't look at it, but then sometime around the spring last year, it seemed that the models had been trained on notebooks, and 90% of the code in Hopsworks is written in notebooks. So as soon as that capability came into the LLMs, they could write the code. They're really good. So I think the lesson learned here is that if you're developing a framework and you want LLMs to generate code for your framework, you have to do API first development. Right? So get your API done, make it as stable as possible, and get as many examples of it out there on places like GitHub so that the LLMs can train on it. And if your API is not stable, it's going to be really difficult for you to leverage LLMs to generate code for your framework. So what else? So what happens if APIs are never always stable; they often change over time. So how can you get around that? Well, you can work with prompts. You can basically, if you're going to build a tool to generate code, you can say in the prompts, I want to insert some code. You should use version 3 of this API, not version 2. Here's an example of what version 3 code looks like. And then the LLM can use that information in the prompt to basically create correct code. You can also use RAG, retrieval augmented generation, I'll talk about in a minute, where we can go to an external data store. So maybe it's going to be a vector database or maybe some other data store. But get examples that we can then include in the prompt that the LLM will be able to generate correct code. The other thing that we often want to do when we're writing programs with LLMs is that we want to interact with external systems. Maybe there's some data there that we need to use. And one way of doing that is using what's called function calling. So getting your LLM, when you ask a question, you write a prompt, it's going to have a set of available functions, and it's going to select the most appropriate function, fill in the parameters, and then execute that function. That works really well in Python. Right? And again, it's due to the imperative nature of Python, and a Python function can do whatever you want. So in our platform Hopsworks, we use it to go to the lakehouse, go to an online database and get data back, and you can use it for many other things with function calling. So the LLM by itself is not going to be enough to help you build systems, AI systems, or any systems, because even though the LLM has this compressed world knowledge, and we can fine-tune it with new examples, there's probably going to be some real-time knowledge that we need to integrate with RAG. We probably will need to integrate with external systems or external data stores, and we'll need to use something like function calling to do this. So if you're going to build a system that's going to generate programs for a specific domain, you're going to have to integrate all of this infrastructure into your solution. So they're the two main, I'll get to it a little bit later, but we're working on this at Hopsworks, and they're the two main pieces of infrastructure that we add to make this work. So I'm going to give a call out now to a very interesting online service I discovered earlier this year. It's been around for a year, actually, quite a lot, and they have a lot of users. And the users are mostly people who work in research. So, I work in research and computer science, but we have tons of researchers in the life sciences who haven't got a programming background. And a lot of what they do is they generate data. They do studies, they collect data, and then they have the nightmare of, I need to analyze my data. And then they maybe look at some R, and some of the better ones write some Python code, maybe they use pandas. And all they want to do is show me the statistical significance of this particular study, and calculate the standard deviation or the confidence intervals or whatever. So what Julie's AI does is you can upload. It's it's a web application. You could upload a CSV file, an Excel file, that could be your study. And you basically ask it to do things. You can ask it, say, for example, generate a plot, and this is an example of the website, generate a plot of the annual salary in relation to ethnicity and gender, and it generates this plot we can see on the right-hand side. So what it's actually doing is it's creating a small pandas program. So it's going to upload the CSV file, store it as a local file, and then it'll write a pandas program which will read up the CSV file. What's interesting is when you try it out, is that sometimes you have, let's call them non-standard CSV files. Like I was working with one recently, it had a semicolon separating the columns, and had spaces there. And what happened with Julius is it read it up, and pandas.read CSV failed, and it gave an error. And then it fed the error back into the LLM, and it said the separator should be semicolon. So I didn't have to do anything. This was all done transparently. I just uploaded it. It said, oh, I've got a little error message because of the way that the separators are written. I'm going to fix it. It fixed it. And then it said, okay, now the data's loaded. And then you can basically say, please plot this chart, and it will write some code for you. In this case, it wrote it in Plotly. But it can write matplotlib, I think, as well. And then you get these nice graphs. And this is pretty cool, right? If you're a researcher and you don't like programming and find it difficult, you can upload your code, you can get these nice plots, and you can download the Python program. And then you can make sure that, does this thing work as expected? So it self-corrects by passing errors back into the programs. The good thing about this, let's call it the easy thing about this domain, is that you're just doing dashboards, right? There's no what we call side effects. I'm not updating an external store. If I write some bad data to an external store, I got to delete that data now. All you're doing is generating dashboards, and the user can say reject or accept the dashboard and continue. So this is a pretty nice service. But what it shows, I think what I found interesting about this is that LLMs can reliably generate pandas code. And as we saw already, that they can't reliably generate SQL code. So I'm going to move on and talk a bit about how we generate an AI system with LLMs. So how are we going to build an AI system with LLMs and Python? And I mentioned this already, but prompting, people say prompting, what is prompting? It's kind of, it's just hacking, there's nothing to it. But prompting is actually, is something you're doing strategically. You're trying to evoke knowledge from the LLM. The LLM has a lot of knowledge of the world, but you need to prompt it correctly to extract that knowledge from it. It won't necessarily give you the right answer immediately. So one of the challenges is the knowledge is not in the LLM. If it's real-time data that was only available after the LLM was trained, you'll need to add RAG into that and through augmented generation. But LLM prompting is not a hack. We should stop thinking of it as a hack. Prompting is a way to get an LLM to generate a correct program in this case. And it will need guidance to get there. The kind of problems that you might have are things like, the LLM generates a program with a deprecated version of the API. We need to make sure that when we're building the system to generate these programs that we can prompt it with the prompt examples with the newer API so that it makes it correct. And there's a nice research paper about this link below. So I'm going to do an example now just to show you something that I've done. This is from my book, so I'm writing this book for O'Reilly. It's not finished yet, but there's 5 chapters available. And in the book, it's about building AI systems, primarily with a stateful layer called feature store. And what I have as a working example is building an AI system that predicts credit card fraud. So in credit card fraud, it's a real-time AI problem. So credit card transaction arrives. We take the credit card transaction, and we need to now make a prediction: is this fraud or not fraud? So I have a machine learning model that's trained on that, but the problem is that the request that came in only contained the current credit card transaction. And to predict fraud, I need to know history. I need to know, how many times was this credit card used in the last hour, last day, how much money was spent, where was the last transaction for this credit card? Was it a physical point of service terminal, or was it online? And with that, I can identify a geographic attack or maybe a chain attack where there's lots of small usages of the credit card. So one of the problems with this for the book, of course, is that there's no one's giving you an open source data set on credit card transactions. There just isn't any on the internet, right? So what you end up doing is you end up saying, okay, I need to generate a synthetic data set. So I'd done this, a year ago or something. And then I thought, well, hang on, can I do this with an LLM? This is something you get a lot of domains. Data won't be available. You like to have synthetic data. And there are companies, there's a whole industry called synthetic data. It's worth, I don't know, a lot of money. but can I get an LLM to generate synthetic data for me? So this is what I have as an example. I'll run the code as well. So I have written here, below these instructions, you'll find 6 descriptions of tables, different tables. Write a Polars program, because Polars is cool and Pandas is slow, to generate the data for these tables of 6 different data frames. Use Polars expressions for efficiency. So if I don't tell you the Polar expressions, it can write really bad for loops, right, that are not going to scale. If you can't use Polar expressions, use the Faker library, that's okay. So I have some knowledge embedded in here. I know that the Faker library is a good way of generating synthetic data. And then I add a little last line. The data frames that you create, write them to these tables we call feature groups and Hopsworks. So let me show you what happened here for this. So this is OpenAI. I use Claude is actually probably better for those of you who are curious. And I pasted in my tables. Now, let me show you the tables first, because I think that's very important. This wasn't something I came with overnight. It took a little bit of time. So this is about your domain. So the table definitions that I need to create the program, which is going to generate synthetic data, need a lot of details. This is something called a logical model for data engineering. So this is actually a table. I've got a table called merchant details. I give a little description of it. I say the size, the number of rows in the table that I want, and then I define the columns. But you can see there's a lot of details, isn't there? There's a lot of details. Say I've got a merchant ID column, a last modified column, a country column, a count charge back previous week column, and a description of all of those. And sometimes I've got cardinality. And in other ones I have a distribution saying, this is a numeric, in this case the date time. I'd like the values to be uniformly random over the previous 3 years from the current date. So there's quite a lot of information in here. Right? So you can kind of think, well, LLMs are great for doing this, but in order to generate correct data, this is as much data details I have to give it in order to work good. And this is another example of the credit card transactions themselves. I need 2 million rows this time. And then I give it a lot of details around, so things like, for example, I've got this one category. There's something called merchant category codes. And I wrote this before, and I removed cardinality 500 types. And it kind of didn't really work. It just gave me like 10 categories. But in fact, in the merchant category codes, it was like 500 types. But if I didn't tell it that, it would hallucinate a bit. So, what you end up doing is an iterative process of saying, okay, I can see that's slightly off. And so you do need to know enough. But what I didn't need to know here, and this is what's interesting, a lot of people would go back to our Hacker News example. A lot of people would be skeptical and say, come on, like this specification you wrote, that's basically equivalent to writing a program. So, come on. What did you save? You didn't save any time there. And I did. I saved a ton of time. I didn't know how to write Polars expressions. Don't really know the Faker API. Didn't know how to create the columns with expected data distribution cardinality in Polars as expressions. That's kind of, something I hadn't done before. Didn't know how to build the data frames composed of these different columns, and then how to persistent analysis. Didn't know any of these APIs. So I didn't really need to learn them to get this to work. And I think that's the key insight here. I know about the data, I can define the data here, but the program to generate that synthetic data, and this is the OpenAI example here, and it creates quite a big program, right? You can see, I'll show it to you in Hopsworks here. So this is running in a Jupyter notebook. Generate merchant details. You can see here that it's written some code here. It's quite a long program, right? Although it's what it's doing is very restricted. So there's a lot of things I can do to make it better. So it's generated all these data frames at this point. It's generating our data frames. We've got 6 data frames it's generated, and then it needs to insert them into these tables in Hopsworks. And this code I could obviously make much better. I could have written a function and parameterized it by the name and primary key and description, but instead it kind of generates a lot of, let's call it non-dry code. You could make it a little bit better, a little more compact. But the answer, I guess the question is here, does it really matter? So what happened at the end of this is I got all of this data in here. And it's great. It's put some data in here, got some synthetic data I can play around with. And it wasn't very much work on my part to do this. I just basically had to kind of prompt the thing and they kind of get up and running. And we can see all of the data created in there. So that's really cool. It's kind of helping my productivity quite a lot. And that's in the book. So in the book, this is what I say, okay, this is you want to create your data, let's just go ahead and do this. And then you might ask, okay, But does that work, right? Like if this is just a very simple example of synthetic data. Let's do one in real time here. So I'm asking it here, it's hard to read, but let me just say what it's doing. This is a talk I gave here in May. I have an AI system that predicts air quality. So what I need to do is I need weather data to predict air quality. So I basically ask it, write a Python program that downloads historical daily weather from New York City, add a parameter for the number of days to download, maybe 1,000 days by default, use the OpenMeteo API. That's some domain knowledge I have, that's a good API. It doesn't need an API key, and then the parameters I want are, the features I want are temperature, wind direction, wind speed, and precipitation, and then I get say conflict. And this works, you know, I can paste this into a notebook, run it, it'll go to the internet, download the data, and it'll then store that data in Hopsworks, and I can go and use it to train models.
Oh, so would you show the prompt again?
The prompt, okay, yeah, there's the prompt up there. You can download the chapter in the book as well, you can read it in there. But I think it's available online. But yeah, that's basically it, right? So, so now we can see, like, okay, they can do a bit more, but can they do more than that, right? I'm not going to go through running this one, but this is an interesting one I did last week, which is to do composition of data transformation functions. So one thing we do a lot in feature engineering is we often have a lot of fact data. So in this case, the data is related to the credit card transactions. And what I'd like to have are one-day aggregations of credit card transactions. So maybe I want to have the amount spent per credit card over one day. But then it's useful to have longer-term signals over a week or maybe a month. And they're also helpful for fraud. So what you can do is you can say, okay, what I can do is I can say, write a program that generates 1 day, 7 day, and 30-day aggregations of the credit card data. And what it will do is it'll process the data. It'll process data 3 times, one for each aggregation. It's going to be quite inefficient. And so what I did instead, I said, well, first compute the 1 day the 1 day aggregations, and then compute the 7 day from the previously computed 1 day aggregation. So it's a composition of functions. And I needed to give it a hint for how to do that when we talk about the amount spent on a credit card, because it needs to use something called weighted average. You can't just take the average of all of them. We need to know the number of transactions per day, so it adds a column for that as well. So it's pretty powerful for writing data processing code here. Okay, so I'm going to move on a little bit to say about, okay, well, how do I build an AI system from this? One of the starting points is that an AI system, often we talk about end-to-end AI systems, but you can't do that, right? You can't build really big programs with LLMs. It doesn't work today. What you can do instead is have very small, well-defined modules that you can test and do one thing, and that works really well. I want to compose those modules into a whole system. So the way we can do that with an AI system, and this is covered in the book a lot, is that we can decompose an AI system into a feature pipeline that takes data, transforms it into features and labels. We can have another program, a training pipeline, that takes those features and labels, trains them and outputs a model, and then we have an inference pipeline, whether it's batch or real time, which takes the new data, the model that's being trained, and makes predictions. And that's our AI system. So we've got nice standardized interfaces. So what we do in Hopsworks is we provide a data frame API, where your feature pipelines write out data frames, training pipeline reads the data frames, outputs a model, and the inference pipeline reads the new data and the model and makes predictions. So this is pretty good, because now I can generate these small programs one by one, and we can use those then to create our AI system. Now, I actually already went through the example of creating a feature pipeline. That's what we did already. We're taking the credit card data, or we're taking the air quality data, and we're creating the features that way. But what I need to do is then create a training pipeline. Now, I'm not going to go run through this code, I won't have time, but I can write a prompt like the following. So I want a Python program, I'm going to use Hopsworks. Now we need to know a little bit about how Hopsworks works. We have these things called feature groups, tables of data. And we have a feature view, which is a selection of features across all of those. I need to know how to split the data. I need to know what type of model framework I want to use, XGBoost, regressor. So I need to know quite a lot in order to write this prompt, which will generate the program. But this actually does work. And then I need to save the model and evaluate the model. So there's quite a bit to do in it. And the problem with this is that, like, I can write this prompt, and I'm kind of experienced, so that's pretty easy. But what if I want a new person who doesn't really know AI too much, but can follow instructions? Can we make that a bit easier? And we can, with something called agentic workflows, where we know exactly what the steps are going to be to create the program. So rather than having maybe a free-form prompt with some text that goes in, we can break down the steps to generate that program into a number of steps that the user can follow. So the first thing they'll need to do is select the features they want to use for their model. That's something called a feature view. They'll need to say what column is the target or label. And you need to say what type of model you want to train. Here, of course, an LLM can help you and say, well, I think this is a regression problem or a classification problem. The data volume is large, so we can use deep learning, or it's small, we can use XGBoost. And then we need to create our training data. How are we going to split it? Then we need to evaluate the performance of our model on the test data, and then save the model along with any evaluation data, so maybe plots of the evaluations of the model. So there's quite a lot to do here, but the thing is, it's a very structured set of steps, particularly for decision tree models. And then for inference, when we want to make predictions, it's again a very structured set of steps. We want to select our model, we want to say, where is the new inference data going to come from? Is it going to be yesterday's data I'm going to make a prediction on, or is it going to be maybe the weather forecast for the next 7 days, or is it going to be all the credit card data that arrived yesterday, or the latest feature values for users? You basically select the inference data you want to use. Then you need to say, well, am I going to log all these predictions? Am I going to do monitoring on them? Where are the predictions going to be output? Will it be a dashboard like Julius, or will it be a database? It's a very structured set of steps you need to follow to build these pipelines. So here's some of the challenges that we're working on this particular problem, and here's some of the challenges that we've been addressing so far, and related to RAG, the task that we're trying to complete, the agentic workflow for that task, and then how we evaluate them. So the first thing is, in RAG, we need to have a lot of metadata in particular, right? So if I've got files with data, or I've got tables with data, and columns and models, you need to have as much metadata as you can. And then one of the challenges is the prompt is finite size. So if I've got a data warehouse or Hopsworks with hundreds or thousands of tables, I want to selectively include some of those. So just to show you like an example of where we're a little bit different. So here I've got a bunch of tables with feature groups. If we pick one of them here, the transactions that we talked about already, we see there's a description for this. It's about credit card transaction data. Every column has a description. So I've got this fraud label that tells me, it describes it. So typically, normally databases don't have that level of metadata around columns. So you'll need to somehow get that metadata if you want your LLM to help you with deciding what data to use. The second challenge, if we're going to build these pipelines, is that these feature training inference pipeline programs, they're not idempotent. So when we went back to Julius, I could rerun the program, no big deal, it's just redrawing a graph or a plot. What if my program's going to update some data in the database, or if it's going to update a model? I don't really want to run that if there's an error in the program. So I need to mop the stateful APIs to be able to do that. Sometimes I'll need libraries. I need to pip install them as part of the program. And then another more challenging thing is, how do I size the job? So if we have good metadata about our data sources, we'll know that there's millions of rows in this table, this one's quite small, then we'll be able to know how big the job should be if we're going to run these pipelines. And if you're doing testing in your container, you might need to restart your container. So this isn't working at the moment, there's not enough resource in it, I need to restart it to give it more resources. Another challenge is, how do you provide the user interface to users to help them guide them creating these programs or pipelines? Conversational text is great, and power users will continue to use that. But new users often like to be guided along the journey. So, the old days we used to use the term wizard. So the wizard is like you click some forms, dialogues, and they can be faster. But there will be other ways, like having a CSV file you can fill in and uploading, and there's going to be many more power user ways of developing these programs. And then the last test is a very important one. Again, it's that when you finally are happy that you have a system that's generating code correctly for you, you need to make sure that it continues to work, because everything will change under the surface. There'll be a new release of the model from OpenAI or from Claude. There's going to be changes in the RAG data that's available for you, and you need to be able to make sure that your system will continue working correctly. So what people have aligned on right now is something called evals, is the term that we use. It's effectively an evaluation data set. You have a number of test cases, you have an input string, maybe system context, and you have an output, and you need to somehow evaluate, is that okay? Now, in our case, we're creating programs, we're talking about primarily, so we can actually then try and run those programs, make sure that they're correct. And if there's a change to OpenAI's model, and we see that the programs start failing, well then we know, okay, you need to fix this. But if you only find that out when your users start using it, that's pretty bad, right? So you want to have this as automated testing to make sure that you check. The other thing, of course, that will change is APIs will change for frameworks, and you need to test against that. So I mentioned we're working on this. This is kind of what we're doing. You know, we have this is Hopsworks here. This is the toolkit dark mode version. I'm an old guy, so it's not really my thing, but so you can basically write in hints and prompts here to generate Python programs, it will test them and so on, and it will help you build these AI systems. So where are we going? Where are we at the moment? And I think LLMs are heralding a new era of programming. I mentioned before that I'm using them extensively. I think many people are to create code. They are a form of compiler now for programming languages, effectively. I think at a high level, because they have good information retrieval characteristics, read the manual is now not something people are doing as much. They're just feeding their errors into LLMs, getting back how to fix it, and that's the kind of the loop people are using to develop code. You can automate, so when you're generating these programs, you can automate the code fixing. You basically run the program, but you need to make sure these programs are idempotent and side effect free. Obviously, small changes in things can break. You need evals, so if models change their behavior, everything kind of goes heads up. And I think my particular interest is, what do we need to do now? What's the education we need to do to get people to write programs with LLMs? So, you know, of course, we'll still need the concepts and abstractions. Maybe some of the detail around syntax will be less important. But how do we also help people, you know, be more effective with knowledge communication, and also how do we integrate the kind of meta-level problem of information retrieval? What's the best way to approach this? I want to make this, you know, more efficient or more performant. And one thing I haven't touched on at all is there's massive security challenges here. So it can be leaks of data everywhere. But that's another day's work. So if you want to learn more, and you know, part of this is coming into this book, and you know, if you want to try out Hopsworks to build AI systems and future training inference pipelines, you can go there. With that, I'll say thank you and enjoy the rest of the day.